Hi everyone, my name is Halit.
And today is the time to share our long-lasting project with you. I want to make vlogs about this project,
And my plan is to post every 1 or 2 weeks. This first video will show current results of our project. And the further videos will be about how this project comes to this stage and how we can use it with some sample projects. Without further ado, here it is. What you're seeing right now is called BitBoard Bir. BitBoard Bir is an ESP32 based microcontroller with built-in 1.3-inch TFT display, and it has 24 GPIO, which you can access with header pins. BitBoard's main focus is to help people prototyping their ideas easily and fast. While making this project, I considered two kinds of makers especially. For those who do their electronics, robotics or programming projects on microcontroller with using Arduino or MicroPython languages. And for those who wants to make their logic circuits usable in real electronics or just want to see their circuits on their hand. This video split into two parts for that reason. Let's start with the first part. One of my intention is to fill a gap in a maker community by making it usable in a logic circuit projects as a basic, small and cheap FPGA-like device. But what do I mean by FPGA-like? You may or may not know about FPGA, but in short, FPGAs or field programmable gate array are configurable electronic devices that contains an array of programmable logic blocks and the interconnects. They can be customized by the user or designer after the manufacturing, enabling the implementation of various digital circuits and systems. FPGAs provide a convenient and cost-efficient alternative for designing and manufacturing custom silicon chips. Unlike the complex and time-consuming process involved in creating a new silicon chip, FPGAs offer ease and flexibility. However, no matter how much FPGA reduce the price and difficulty of use, it is still be expensive and difficult for many reasons. There are alternative chips called PAL or PLA that cheaper and easier than FPGA. But these chips limited by their capacities, caused by their smaller scale and limited resources, which constrain the complexity and the size of the circuit they can accommodate. My solution is to make a circuit simulator that can run on all kinds of microcontroller and work like any other logic simulator software, like LogicSim, Logically, or virtual circuit board. But with much more features. One of the most important difference of our simulator is that it can be used as a generic logic simulator running on your computer, as well as being able to run on BitBoard using all its capabilities. Current version of firmware that runs logic circuits is still making lots of progress. But by now, it can simulate your circuits up to 10 kHz in parallel. That means your circuit will be simulated 10,000 times every second. I know, our speed is not comparable with the APGA or PLA's speed, but in smaller scale projects, it will meet our requirements just for now. This board will not replace your FPGAs. I don't want to make a replacement for anything. I just want to give people a new tool to play and discover new ways to making things. I think these tools and products are like a gunpowder of creativity, and when they meet someone's spark, they explode to form of everything we love in this hobby. We are not just making our own logic simulator that will make same thing as other logic simulators do. We want to use all capabilities of BitBoard Bir. Because of that, in our logic simulator, you can implement lots of different input and output device, other than Boolean I/O. I mean, if we can read analog signals with it, why don't we use this 12-bit data in our logic simulator? Or controlling a servo motor with PWM, displaying a number on 7-segment display, reading data from ultrasonic sensor, sending or receiving data from UART, I2C and SPI protocols, displaying image on 8x8 LED matrix display. Use your internal or external EEPROM to read and write data and much more that I can remember right now. There is no limit for that. You can use all kinds of electronic components in your logic circuits. This feature is for those who wants to use their logic circuits in robotics, basic electronics, or pipelining protocol format conversions, etc. But you can add to these as much as you like. I probably use it my own 8-bit breadboard computer to test some of the CPU sections before I build those on the breadboard to see beforehand if my logic works or not. You can use those features within our two different logic simulators. One is visually much more similar to the silicon die and has only NOT gate and the diode components to make your circuits. Less component means you need to create your own logic gates on top of these two components. And the other one is generic looking logic simulator that contains lots of logic gate in it and has a modular system that helps users to manage their circuits. Both simulators have some strong and weak sides on the simulation and the designing part that will help people in the different ways. Also, you can see your simulations on BitBoards on display and observe what is going on in your circuits while it's running. Now let's see the other side of the BitBoard Bir and talk about what we can do with it while we are programming it. As I said, you can program it with Arduino and MicroPython languages. You can control 24 GPIO pins, which 12 of them can be used for ADC, and it supports I2C, SPI and OART protocols. Its internal clock runs up to 240 MHz and its wireless module supports PLA and Wi-Fi. In short, this board can do anything that ESP32 S3 can do, but we have some additions to its base form. Our addition is a TFT display at 240 by 240 resolution with 60-bit RGB colors. You can use this display in your project like making games or designing a GUI for smart device. BitBoard's other secret weapon is the expansion pack that will come separately. I love those plug-and-play design because they are easy to use and do not require electronic wiring or breadboard or prototyping a PCB. When I want to prototype things, for example, a two-wheeled robot or digital compass or a small game console, I usually drop those projects because of the requirements of making electronic design from scratch. I am a usually backend guy, and I want to pass to the programming part as soon as possible in my projects. Those expansion packs will make easy to start and test ideas when you have necessary packs. Currently, there are 8 different packs functioning right now, but some of those packs might be not came out or much more can be added in the future. Now let's look at the packs. 9-axis IMU pack for sensing movement and direction. Environment pack that has light, humidity, temperature sensors and barometer. Controller pack has 2 joysticks, 2 switches, 4 direction buttons and 2 controllable LEDs. Robot pack that has capacity to control up to 14 servos and 2 DC motors. Battery pack has a 1 LiPo battery and can be charged via BitBoard's USB port and can be read how much energy left in the LiPo battery. VGA pack has a VGA port and you can use ESP32 S3's computing power to display images on the monitor. Keyboard pack that has 60 keys with mini keyboard layout. And finally, prototyping board that comes with the bunch of holes which users can make their own expansion packs with it. And it's also breadboard friendly. Also, those packs can be stacked up like this. To combine abilities of those expansion packs. Those are the things I'm working on since February 2022. But I can't come to this point without my family and the co-workers. Especially thanks to PCBWay for sponsoring to my first BitBoard's prototype that works on real PCB with the final form factor. I call it this board VLIC back then. If you want to support my content and the future development, don't forget to leave a like into this video and share with those that you know interested in these topics. See you in the next time.